Alright guys, so last time we talked about systems. So focus in, and with systems, we had lots of different ways, lots of different routes you could have solved this. So, anybody want to share what was like the approach you took to like start it off? Maybe something you noticed to help you get started with this problem. Lots of different things. What did you think about, Yana? And then what did you think about from there? Great job. So I can substitute this y in. Another thing you could have done is solve both of them for y and then just set them equal to each other. It does not matter, right? You are just finding the route that works best, makes the most sense for you. But no matter what route you took, you know, next up you have a quadratic. What you should be looking for is you only have one variable type, as in one letter, right? I shouldn't have x's and y's. I should only have just x's or just y's, which I'm not typically going to have just y's anymore now that I have quadratics involved. So now that I have a quadratic equation, right, I have x squared. What is my first look for with a quadratic equation always? Maybe eventually. Always first thing is
equal to 0.
Yes. So let's get this bad boy equal to 0. So you have 0 equals x squared minus 8x plus 12. Now, let's talk about our next thought when he said greatest common factor. That's starting the process about thinking about can we do what? Can we factor? Could we factor here? Yeah, we could factor. So what did we find those factors to be? You guys figure out those factors? Yes, -2, -6. Could you have used the quadratic formula from here? Yeah, but in my opinion, I think if it's a simple guy like this and you can factor, go ahead and factor. That's going to be much easier. All right, you have your factors, and how do I keep solving? Factor, what do I set my factors equal to? Yes, good job. So I would have x minus 2 equals 0 and x minus 6 equals 0. So you end up with x equals 2 and x equals 6. And I found my x values, so am I done with the problem? No way. What do we still need to find if I know x values? 1. So can I plug it into either or those equations? Yeah, but does one look way easier than the other? Which one's way easier? Which one's way easier? First or second? Yeah, second, it's a linear. So, you know, you already had it y by itself. So, you know your y is going to be equal to 3 times your x value minus 15. So, y here was 3, right? So then, you know, what's our ordered pair? Great. And then we also have 3 times, oh, sorry, why did I was thinking about the next one. Obviously, that should not be 3. That should be -9, right? And then we would have 3 times 6 minus 15, and that is 3. Then our other ordered pair is 6, 3, and we get 2 points, which means this line crosses over through that U-shaped graph how many times? Yeah, so maybe something like this. You cross through here and here. All right, you guys, any system questions you have before we move on? Okay, so let's get started. Like I said, everybody needs to focus today. So if you have phone, computer out, let's put our full attention now into our new best friend. And our new best friend is our TI calculator. So you need to have this TI-84 calculator. I'm going to kind of project things on the screens for your steps. Like I said, if you kind of miss one thing, ask a neighbor really quickly, and then catch back up. So what we're doing today is we are working on regression and some application problems with our calculator. So what is regression? You have done linear regression before with in Algebra 1, right? You've maybe had a table or a set of points, and you found a line of best fit that went through those points. Everyone, those phrases make sense. You've heard those before, right? Line of best fit. So now we're going to do that same thing, but now it's going to be a curve because we're in our world of quadratics. So that's really how math is used in the real world, right? You have a data set that you took data from, or you're analyzing this data set, and you're trying to create a model that's going to be used to predict values. So we're going to start with example 1. So why don't you guys take a minute on your paper, read over example 1, kind of think about our first question, look at the table, and then we'll get started. Jack, were you able to get into Delta Math okay? Okay. So you're on that quadratic regression handout that I had passed out to you earlier, reading example 1. There you go. All right, so thinking about what we have here is we have a data set, and we want to create a quadratic equation that models this data set. So we're going to use our calculators to do that for us. So what we need to do first is we need to enter this data set into our calculator. So where you guys are going to live today is this stat button. Stat, kind of to the left of those arrows. Go ahead and hit stat, and first comes up edit, which means I'm going to edit a list. You should see list 1, list 2, list 3. If you see list 4, list 5, that means somebody has accidentally deleted a list, which is something we don't want to do. We'll have to reset the calculator. It's not a big deal. Just sit tight for a second. So does everybody see? You might have, like I said, listening, because lots of stuff to get through. Lots of values in here, and I want to clear these values out to enter my data set that I have. So to clear out the values of my list, hit the up arrow, so now you're highlighted over the whole list. Hit the clear button. Do not hit enter because that will delete your whole list. Instead, hit the down arrow. So up arrow, clear button, down arrow. So clear your list. So you should have clear, like a clear list 1, list 2, list 3 here. Just take a second and do that. If not, you might have to go through and individually clear each item, which super tedious. We don't want to do. Stat edit. Enter. Got it. Yeah. Up, clear, down. Great question by Akash. He just said my L1 and my L2 are missing. That means somebody in my first period accidentally deleted those lists because they hit enter instead of the down arrow. So I'm going to have to reset that calculator. So if that happened to you, just raise your hand real quick and I'll take care of it. So now you're going to go ahead and enter the values from your table. So thinking about a table when you're given a table, what values are typically on the left? X. And then what's on the right? Great. L1 is always going to represent your X values. L2 is going to represent your Y. So in your table that you're given with example 1, what do we think amount of paper represents? X or Y? X. So that those values you have are going to go in list 1. Those values for production costs are going to go in list 2. So do one list at a time. So, for example, we would do like 0, 2, 4, 5, yada, yada. And keep in your list 1. And then To get to your list 2, just right arrow over. So we're going to take a minute and enter our data. And if you finish early, what I want you to do is just double check to make sure you entered all the right data values. All right, so let's take 30 more seconds. Once again, the only way you might get something different than me is if you just do a typo, right? Like maybe you accidentally entered 34 instead of 35, so your values would be a little off. So just always double check your data set once you have it all entered. You would get an error if you try to keep moving forward if you forgot one of your points, because every X needs to have a corresponding Y value. So what are we going to do with this data set? We are going to model, which means create an equation. So therefore, we're running this regression model to help us get there. So where we're going to go next is, once again, back to our favorite button of the day, which is our stat button. But now I want to calculate this regression model, which means I'm going to right-click over Calc. And let's think about our unit, everybody. What type of regression do you think we might be running? Awesome. Which is what number? 5. So you can hit 5 or just scroll down and hit enter. So my calculator is not updated. So you might see on yours that you would have X list L1, Y list L2. So that means, yes, are your X's in list 1? Yes. Are your Y's in list 2? Yes. So scroll down until you see calculate, highlight over calculate, and hit enter. And now your screen should look like mine. So hit enter. Oh, so it should look like this? Does your screen look like my screen? Yeah. Good job. All right, so your screen should look like my screen, which this is our regression purpose. It gives us these values for our quadratic equation in which forms? Standard form, you're right. So if I'm thinking about writing this equation here, I have my A value, my B value, and my C value. So all we have to do to write our equation is just replace A, B, and C with what we're given. So we know our equation would be y equals 0.75, x squared, was it minus 9? Perfect. And then 50? Okay, plus 50. Sorry, what? That is a great question. Did yours give you a fraction? So we are now, with today, it's a lot of application stuff. And when you're talking about applications, lots of stuff is kind of in terms of time or money. And you're typically not going to use fractions, or if we're talking about simplifying a radical, right, with our quadratic formula. Do I ever talk about money in terms of square roots? No, you talk about money in terms of decimals. So kind of with today, really focus in on your values being decimal answers. Does that make sense why you're going to do that? Yeah. So think about just context of your problem. So now we want to find the vertex and axis of symmetry. So thinking about this is my equation here. I want to use those ideas we talked about last unit to find the vertex. And how can I always find a vertex? I could put this all in vertex form, but that seems like a lot more work. What's a little easier is knowing the fact that your x value from your vertex is minus b over 2a. Don't we know that? We do know that. So you know the x value for your vertex is minus b over 2a. So if we can find that x value, then we can keep moving from there. So let's find that x value using our equation. So we know minus b would end up being positive 9 over 2 times 0.75. And if you're thinking about using your calculator to do this, when using your calculator, you're going to do 9 divided by, and then your whole denominator, what you're dividing all of everything by, has to be in parentheses. So this would now be 2 times 0.75. Because if not, what it might do is it might do 9 divided by 2 and then multiply that by 0.75. So that's the difference there. So just keep that in mind moving forward. While we're learning about how to use our calculator, so we know our x value is 6 for our vertex, which means if I know the x value for my vertex, I want to find what? Y. And how could I always find a y value if I know an x? Substitute it. There you go. So basically, instead of x here, you're going to replace it with 6. So you can go ahead and just kind of use your calculator with that. And as you substitute, put parentheses around the value you're substituting x for. And square on the outside. I would say that was probably one of our biggest mistakes from our last unit test, right? What's always a negative squared? A positive, right? Some of us, I think we're incorrectly using the calculator, so it's giving you the wrong value. So make sure you're doing that to get the correct value there. And once you plug in 6, you should find that the output is 23. Now, what would our equation for our axis of symmetry be? Think about that while I answer the phone real quick. Hello? Yes. Yep. Evan, do you know that's for you? So go check out the sub-school and what do you guys think? How do you find your axis of symmetry if you know this is your vertex? Think about your axis of symmetry is it cuts it in half, right? So what type of line? Vertical. So how do I write a vertical? Yes, x equals 6. All right, so now let's talk about our next question, which is part D. Find the cost of producing 12,000 pounds of paper. So what's some key words we have for part D? Oh, my bad. I was jumping the gun. We have to talk about part C. So let's find the amount of paper that should be produced in order to minimize costs. So what are some key words with part C? What do you think, Laura? Ooh, good, minimize. So thinking about my quadratic here, look at my A value. My A value is positive, which means my quadratic looks something like this. Where would your where would that minimize, where do you think that, yes, that's our vertex point, right? That is an absolute minimum. So basically this question was asking you to think about your vertex point, because that's your minimum point. And we already found the vertex, didn't we? Yes, we did. Now let's answer the question. What's the amount of paper that would minimize costs? 6, but in context of your problem, it would be 6 what? Pounds. Good job. Now, let's think about question part D, back to that guy. So now let's find the cost of producing 12,000 pounds of paper. What's some key phrases there? We want to find something always. What else do we know? Yes, 12,000 pounds of paper. What value does that correlate with? Is that an X or a Y? X. So your X value is really what here? Yes, good. I heard somebody say it's 12, right? Because everything was in terms of thousands, pounds. So if I know basically X should be 12, we want to find the output with that. How can I find the output with that? You just plug it in. Hey, there we go. And guys, do I have a trick for you? Are you ready for this trick? This trick is called copy and pasting. So how we copy and paste with our TI is if you're on this, if you have not hit cleared yet, if you've hit cleared, I'm sorry, you missed your opportunity. But, oh, my calculator is not updated and old, but on yours, if you see that line with your like 0.75 and you did 6 squared, hit the up arrow, and then so you can highlight over that. Yeah, so get that line highlighted by hitting the up arrow like maybe a couple times. Hit enter. And that is how you copy and paste it. So now what you're going to do is you're going to replace 6 with what number? 12. There you go. So that can be a little shortcut there for you. So then oh, but you know what? If it's like not the, yeah, right here, and then you'd have to do parentheses after plus. We go here. I said you gotta focus. You can't be messing around.
Honestly, I don't understand. I had a case on it. Oh, my case was on.
So that's where the goal is from.
It just didn't feel like
Here,
How do you break it? I guess I dropped
That's all we
I
do.
don't know, because I just Miss Shepherd has this minutes charging spontaneously.
Wait, and then Miss Shepherd.
It's like yellow. Like the color is changing.
I would assume.
Imagine that's the battery like leaking.
How do we get 6,000?
Yeah, it's like that.
You found minus b over 2a for your vertex.
So that's it. Oh, you love that.
Oh, you did?
What if it's like upside down?
Then it would set a minimum. It might say what word instead. There you go. All right, guys. When you input 12 for x, what do you find the output to be? 50? Okay, but in context of the problem, that means
5,000.
good. Oh, and it's dollars. You guys, remember dollar sign. It's front.
Would you take points off?
Yes. So, all right, so part E says how much paper would result in $4,000 of production costs. So what are some key phrases there?
4,000.
Yeah, and what does that really represent, or what value? Y. But Y would mean, am I going to use 4,000 for Y?
40.
Yes, divided by 100, so it's going to be 40. So 40 is my Y, and now, think about it, instead of Y, we used 40, and then have it equal to that equation you had, which was 0.75 x squared minus 9x plus, this is 50, Ooh, and what does this look like we're about to do? We have a quadratic equation, so we want it equal to?
0.
You guys, I'm so glad we know that. Now that I'm at quadratic equal to 0, what do you think I'm going to use to help me solve for these x values? Or solve for x? Yeah, this looks way too ugly to factor, right? So just go ahead and start using your quadratic formula to help you solve. And when you get there, go ahead, if you end up with a decimal, right, that's okay. Just round it to like 2 decimal places, that's okay.
What do you do when you get like a decimal in the denominator? Do you just multiply it by the...
You just divide by that number, it's okay. So you just
Okay.
divide by 1.5.
It's not okay.
Just divide by 1.5, it's really going to be okay.
Which one's just reminds me?
Yeah, so when you have to do the plus or minus, just scroll back up, copy and paste.
What's the square root?
Oh, great question. Square root, notice it's in blue over x squared, so you have to hit the blue button first, which is second, and then the x squared button.
Take it out of the square root.
So, if I'm talking about like amounts of things and like costs, like I would think to be decimals, not like radicals.
Okay.
You know what I mean?
Yeah.
Like if you were working for a company, do you think it would have made sense like, oh, I need 9 plus the square root of 51 reams of paper? No, you would have
Yes, I
said
need
like
that.
9.72.
But I need 71414.
Right, so just round it to like 7.1.
Okay.
So you just have to use like the day to rest.
Okay, okay.
What do you mean?
Like, it's always not gonna be one.
Oh, no. There's 2 solutions that work. But what you're thinking about is like maybe like time whenever we can set it's like I would have like find a negative because that would work.
I actually
I hear what you're saying.
I would if you had $4,000.
Yeah, right?
I didn't know the one that I could like in terms of pay. I didn't know the second part. There were a couple on the back that were tricky.
Alright guys, a couple of good questions. Once again, am I going to talk about like things about like reams of paper cost in terms of like square roots? No, we're going to just kind of use those decimals. And remember, you can just round to like 2 decimal places. So you're doing 9 plus 7.14 divided all by 1.5 to get 10.76. And then you get 9 minus 7.14 divided by 1.5 to get 1.24. So those are your 2 solutions here. And in this case, based off of the context of the problem, it makes sense to have 2 solutions. But sometimes, and you'll see it later, it might not make sense to have both solutions. Evan, did you have a question?
Does that mean you can even have one piece of paper like 10?
Yeah, but it's 1,000 pounds, right? Yeah. Uh-huh.
It's like placing on miles or whatever, and you get like one positive negative answer.
You are getting there. We're gonna get there. You're thinking like you're thinking a couple examples that we'll get to. All right, guys. Any other questions here? All right. Are you guys ready to do? Are you ready to do this all over again with example 2? No. Same but a little different. So I will let you guys know with the questions where it's like example 2 and example 3, it asks you to create a scatter plot. We're going to skip that today because I want to, it's just one more calculator step to throw at you, and that to me is not important for today because we're only dealing with quadratic regression today. In the future, like after winter break, you're going to have to determine what type of regression works best. So that will be important then. But for right now, let's just get the basics down, which means I have a data set. And how do I enter my data set into my calculator? How do I? Yes, there we go. And then I hit 1 or enter. And guys, how do I clear?
Go up, clear, down.
Beautiful. So go ahead, clear out your data. Did you just figure that out?
They just said it.
I know. That was quite impressive. So think about my X values go in list 1, which is speed, fuel economy. Y values go in list 2. So let's take a minute and enter our data. So double check, like I make sure you don't make any typos, like I just accidentally hit 25 instead of 35. That is kind of the only really way you might get something different. All right, here we go, everybody. You have your data entered, and we want to find my equation that models this data. Where can we go next to find that equation? Good job. Go back to stat, and where are we going next? Good. Right arrow over to get there. And what's our option?
5.
Yeah.
Calculate.
Yep. And then calculate. So you get these values here. So, alright guys, so if I were you, let's round these values, and alright guys, listening in, don't let rounding be the thing that holds you back here. So let's just round to like 2 decimal places, right? 5 or above, round up. 4 below, keep the same. So, well, our A value will now be negative 0.01 x squared, and then plus 0.746. Oh, sorry, I said 2 decimal places. 0.75 x, and then plus 13.47. Okay, we have our equation for our quadratic. Now, we want to predict the fuel economy at 75 miles per hour. Who has some thoughts? What are some keywords? 75, that's my miles per hour, which means it's my what value? It's my x. X is 75, so that means I'm looking now for my what? My y. So to find the y, what are we going to do?
Plug it in.
There we go, plug it in. So go ahead, start calculating that. So instead of x, put parentheses around 75 for your equation. Yep. So, see how yours are just a little different than mine? If you go back here, I bet you have a typo somewhere. So let's look. See, you're like 2.5. And it'll throw things off right, because this is like data, so like everybody really counts. Okay. Right, click over to calculate. No, it is. You have to do it though, right?
What do you
Insert a calculator.
I don't believe this.
And if your values are a little different, I bet you have a typo. So just go back and double check your data set.
It's good. -315.
Do you think it would make sense to have negative fuel economy? No, that means if I were you, I would double check my work. This is it. There's a plus sign here that you don't have.
Oh.
So you're just multiplying everything together. So when your x is 75, what do you guys find the output to be? 13.47? 13.47, that's your fuel economy, which is miles per gallon. Oh my goodness. So have you started driving yet? So when you start driving, right, think about your miles per gallon is like how like rate of your gas. Have you heard of like gas mileage? Like I get like good gas mileage on this car. That's like that idea, meaning like I can get like my car got like 30 miles per gallon. So that means I can get like 30 miles in 1 gallon. For my tank. Because I drive a little like Toyota Camry, so I get pretty good gas mileage. So if you were like driving like a big truck, they'd like 12 miles per gallon. So with 1 gallon, they can get like 12 miles because they're like a big engine. Yes. But everyone's just thinking about it. All right, guys. We're almost done with this example. Then you'll try one on your own. So, what's the best speed for maximum fuel economy? So, kind of with all this question, if you haven't started to like drive and think about it. So, if I'm cruising on the highway at a consistent rate, I'm gonna be having a greater fuel, like miles per gallon for my fuel, versus if I'm driving through, having all these stoplights. If I'm going down stoplights driving, I have all these stoplights I have to stop for. That's gonna kind of make me stop and restart. So that's gonna decrease my fuel economy. So we wanted to know what's the best speed for maximum fuel economy. So it's like a keyword in that question. What was that? Maximum. So think about my A value here. My A value is negative. That means my quadratic looks like this. So if I think about my maximum point here, this question is really asking me to find the what? The vertex. Good. And it says what's the best speed for maximum fuel economy, which means I'm focused on what value in my vertex? The x. So how do I find the x value of my vertex? Negative b over 2a. So go ahead and let's calculate that. And remember, do your parentheses when you are dividing. Focus, like I said.
Yeah.
You're gonna miss lots of stuff today. Find the x value for your vertex.
Oh wait, why is it negative again?
Why is what negative?
It says negative, so
Your vertex x value is negative b.
oh wait, yeah, we can negative. And that's basically right?
Yep. Alright guys, so what did you find the best speed to be? Did we get a 237.5? Good. If you got something different, this is what I want you to double check. Did you do parentheses around all those values for your denominator? If not, redo it again and then you'll get the correct. Well, yeah. It's talking about speed. Alright guys, I'm going to have you flip over to the back and everybody is going to use the table here with example 3 and find your equation, and then I want us to pause once you get your equation. Huh? So your equation was that's what we got. And then I said, Scout, I thought we're going to skip that for now because it's really important that you do have different regression models you're running, and for today, so, we'll get there, but like probably after winter break. Uh-huh. Okay, guys. Like I said, get to your quadratic regression. I wanted to talk about something that's weird here, and then I'm going to have you finish out this problem. So, Vivian was kind of already seeing what was weird and want to tell us what was the weird thing you saw.
There's like an E.
There's an E with our which value? Yes. So see how this says e to the negative 4? That is how your calculator represents scientific notation, which means that this is like negative 4.76 times 10 to the negative 4. So if you remember scientific notation, this means I'm going to move my decimal place 4 units to the left. So go 1, 2, 3, 4. Okay, think about that's where my decimal is now. So I'm going to have 3 zeros. And then 4, 7, 6. So that's what your C value is. That is rocket. Oh. So, one sec. So, kind of think about why that makes sense, right? It says my C value is really close to 0. If you had a C value of 0 in your standard form, that kind of showed you graphically that you went through what value? Yes, the origin. So that means, look at your table. Do you have the 0.00? Yeah, that makes sense. That's going to happen like that. So use that for your C value for your equation, and then I want you to work on part C, and then we'll switch gears. We have lots of applications with quadratics. Kind of think about any time you might have things travel in like a curve or an arc. Can anybody think about like a situation when something might be traveling like a curve or an arc? A curveball, kind of if you're throwing, right? If I throw a ball, it kind of will go up a little bit and then down, right? What else might be a situation when things, what do you think, Laura? Oh, yes, going back, like, or even if you're on a swing, if you were to like jump off, right? You may like jump up and then go down. Good. Does anybody have any other ideas?
You're like on a diving board.
And then you like go out
and then down.
Yeah, good stuff, guys. So everybody, thank you. Focus. So now let's get into our applications. So it's going to be lots of the same types of situations that we were just seeing before with regressions, right? Like finding vertexes, solving, or finding specific values. But now it's just a little easier in the sense of you're given the equation for the situation. So thinking about here is I have a counter, and this glass is falling off the counter And this glass is dropped from a height of 4 feet. And think about this glass is traveling down at an arc like this. And it's described by that situation of negative 16t squared plus 4. So h is our height and t is our time. So our question we want to know is, when will this glass hit the ground? So we're going to think about right here is where we would hit the ground. So what do we know based off of our question?
That's height.
I do. What was that? What would that height be for our ground? Oh, not quite. So this is my starting height, but I want to know when the glass will hit the ground.
0.
Yes, good. So my ground height is what? Yes. So height is 0 when you're talking about the ground. And if I'm solving for when, that means I'm solving for what variable? T. So let's replace h with the value we want to find, or the value we know, which is our ground. And now I'm solving my good old friend, this quadratic equation. So, solving our quadratic equation, what's our first thought with the quadratic equation? Do we already have that done? Awesome. What's maybe another thought we might have? Yeah, maybe we might factor, right? So, if you're thinking about factoring this, you might want to factor out a GCF of negative 4. So then you'd have 4t squared minus 1.
What is this?
And then, how can you factor 4t squared minus 1? Anybody know those factors? Smith, or do you know them?
Is it 2t minus 1 times 2t plus 1?
Awesome job. It's that difference of squares. And now that we're factored, we said each factor equal to what? 0. So I'm going to kind of finish that up here. So I would have 2t minus 1 equals 0. And then we also have 2t plus 1 equals 0. So take a second and think about solving for t in both of those. So in our first equation, we would get t equals, what about our second equation? All right, so think about my two solutions that we got here. And my t represented what value? Time. Something like not make sense here. We can't have negative time. So can time equal negative 1/2? No, even though we would love to go back in time, we can't. Our time can only equal 1/2 year. Basically, remember those good old ideas of domain and range? So this situation is described by this function, but your domain, when you're talking about time, domain would always start at what value?
0.
0, good. And probably if I'm talking about height, I'm probably not going to go like below ground, right? So that would always start at 0 as well. So here we only have our time to be one value here, which is 1/2. What other questions do you guys have here? So great question. What if you end up with 2 negative values?
Then the last didn't.
Maybe that might be cue to check your work, right? Maybe that would be like a, I got no solutions for both of these. Like, let's check my work. That might be a good situation. Or maybe the glass and fall, like you just had to think about the problem a little differently. Just depends. All right, why don't you guys take a second and look at our next situation and kind of see what you're noticing about this, and then we'll get started. So working on these examples maybe from your notes you have from your warm-up from the beginning. All right, so we have a batter that hits a baseball that travels at this arc and it's followed by this equation. So if you guys notice, so once again, we had a negative 16t squared. That's kind of like, that represents gravity, right? Gravity is always following at that same rate. And this, your value for your t, represents kind of like your speed. And then, what do you guys think just your constant might always represent? Good job. Where it starts. Girls, please stop talking. Thank you. You're starting, right? Because when t is 0, that's always that first value, right? In our last problem, we started at that. It was +4, right? Because you fell from that height of 4. So think about this ball was hit from that height of 3 to begin with. So we want to know when the ball will hit the ground. So similar to what we just worked on before, what does that mean we're kind of solving for? Oh, what represents 0 here? H. So think about hitting the ground. That means your height is 0. And then we are solving for which variable? T. Good. So thinking about height is 0. What are you guys kind of noticing about the equation you were given? It is a quadratic. Good. What else do you see about it?
It's out of order.
Out of order. So I might rewrite it in that nice standard form order to help me make sure I use my quadratic formula correctly. So with this question, maybe you might try and factor, but maybe you might already be thinking, all right, these numbers are kind of crazy. I just want to kind of use that quadratic formula to help me solve from here. So why don't you guys go ahead and start setting up that quadratic formula to keep solving from here. Finding those t values. And once again, you can round it 2 decimal places. All right, you guys, let's see what you were thinking here. So you should have set up your quadratic formula, get that square root to like be that 65.48 decimals. Anybody want to tell us what they found t to equal from here? What do you see, Morgan?
Negative 0.046 and then 4.046.
All right, so let's think about, I got time to be, first value you said was like a negative number. Does that make sense to have a negative time? No, so then it's only going to be which one?
4.046.
And then we'll just call that 0.05 seconds. All right, good. So now we want to know what's the highest point the ball reaches in its arc. What does that highest point correlate to? What vocabulary term? The vertex. So the highest point, meaning I'm going to use my vertex. I need to know that x value, or t, is going to be minus b over 2a. So let's think about minus b is going to be negative 64 over 2 times a, which would be negative 32. So what does that mean our t value is going to be? 2. So let's think about, does that make sense, right? Think about, I'm getting my highest point around 2 seconds when I reach the ground, kind of go all the way to the ground around 4 seconds. That makes sense, right? It's going to be symmetrical. So that's just the time. So I need to find the highest point, which means I need to find the y, the h. So how can I find the h or my y value if I know this is my time?
Plug it in.
Good job. So why don't you guys go ahead and plug it into your equation and then see what you find. Just remember putting parentheses, squaring the value. Luna, Vita, you guys doing this in your calculator right now to practice? All right, so for you input 2 for your time, what did you guys, anybody want to tell us what was our height? 87? 67? That sounds good for everybody? And then my feet. Mm-hmm. What did you say? Uh-huh. Lots of stuff like that. All right, you guys. Are you ready to try one on your own? Yeah? Let's do it. So you guys try this one.